Hi. Awesome. Okay. I am live now. Sorry, y'all. It's been a couple of minutes trying to actually go live here. Um yeah, I'm just using the web, the YouTube web streaming web app, right, which is really basic. I do have ambitions of actually using some streaming software, but I'm going to switch my main OS, my main operating system on my computer that I use here. I'm in the process of switching it back over to Linux, and I don't want to mess with software streaming stuff until I've made that switch. Because I'm just going to have to do that work. I'd have to just do that work all over again once I get to Linux. So, kind of trying to do both simultaneously, but I do need to prioritize making the switch and getting streaming software up and going. And I already know that that's gonna enable some stuff that I can't do yet that I will be able to do when I do that. So, such as like controlling the size of my image and how it's cropped in the little inset. When I share my screen, the YouTube software just decides how it's going to take the feed of my face and put it on the screen. But at some point, I'll have control over that. So that's exciting. All right, here's this. I had to like completely close out my browser. Like that's the thing that ended up working, was completely closing out my browser. So all my windows and stuff that I had set up I need to get set back up, but it won't take but a moment here. Awesome, there's that. Oh, there's that. There's that. There we go. Okay. Hi, howdy, welcome. Okay, so I do believe I have my various windows up, and I know I have this one at least. Howdy, hi, and welcome. So, I'm going to keep my eye on the question submissions, because that's my priority, is answering your question. But until I get some of your math questions, there's all sorts of other math stuff that pretty much every student can shore up on. Not every student has the same gaps, but there are some pretty common gaps that arise, and one of those is fractions. So I wanted to just go back and review like fractions. Here, excuse me. Review fractions. What are they? How do they work? Build from that understanding. Talk about, okay, so what does it mean to add fractions? And just try to create sort of an intuitive understanding of what a fraction is. And then if we feel like we understand what a fraction is, then just build sensibly from that to, well, how would make sense to combine these fractions together if we want to say add them or subtract them. Potentially, then we can build to multiplication and division, things like that. We actually talked about, I think on my very first stream, the thing I talked about was doing fraction division differently than most people are probably taught, the flip and multiply way. So if you're interested in that one, I'll probably revisit it at some point, especially once I actually have viewers and things like that. And it'll just be nice to redo early videos. But if you're curious about that, you can go watch that. And I sort of build through all of, fraction, addition, subtraction, multiplication, and then why the method I show makes sense for division, why we should expect it, and how it does work. But here, what I want to do today is actually start a step earlier than all of the stuff in there to help explain some of the stuff I sort of skipped over in that one. Like I just uh sort of I we didn't talk about like when you're adding fractions why you need a common denominator and what that common denominator like represents. So that's what I hope to look at today is a little bit sort of the justification just before that. So this is sort of what you might have learned. I kind of want to start as if we're learning what fractions are for the first time. And especially for older students, when we explain concepts like this that you've definitely been introduced to, and because it sort of rings a bell, there's some amount of familiarity, it's really easy to say, oh yeah, I know that. When, yeah, you might recognize some keywords, but if I were to like put some fraction stuff in front of you, would you? If I were to not just put some fraction stuff in front of you, but put a word problem, an applied problem in front of you that required recognizing and working with fractions, but it didn't actually like tell you explicitly what to do, could you do that? And that's what I want to build to, right? And so if you tune in and you see we're going over, some stuff that might seem like it's sort of below your level, maybe still tune in, because my hope is that along the way, especially if you have things to attach to, you're like, yeah, I totally understand that. That's a thing I know. Good. We're going to build on that. My hope is to then fill in some gaps where you're like, oh, I did know, that you need common denominators, but I didn't actually understand what the common denominators actually could represent. That sort of thing. So yeah, I hope to do just all levels of math here. We did some calculus late last week. Did I do it on Sunday? What did I do yesterday? Oh yes, Sundays are kind of the chill stream. Those are 11 to 1 on Sundays. And so I did a lot of housekeeping. So as you can see, there's like nothing here. I came up with this right here, which doesn't seem like much, but it is the product of much fiddling. And it will fulfill something very nice for these streams, but it doesn't look like much. So oh, you know what? I do want to check that the stream is working on my website now. It seems to be. All right. That's what I wanted to see. Go here. And then I guess, yeah, so I want to work on some fraction stuff while I'm waiting for people to maybe pop in, right? The stream started at 3:30, which is right as school lets out. My hope is maybe that especially older students sometimes have free periods, or just, sometimes you end up with a little bit of time at the end of the day where you could sneak away to get ready for like a live stream. My hope is one thing this stream can provide for students is something to attach a homework routine to, at least a math homework routine to, right? So like the stream's going to happen Monday through Thursday after school. Like it's right after school right now, 3:30 to 5. I want to play with those hours a little bit. I am interested in doing some evening or late night streams even, because there's some students that won't even have a chance. You couldn't even dream of starting their math homework before 8 or 9 p.m., right? They just have so much other stuff going on, extracurriculars and other responsibilities. So some late night streams could, I think, be really useful. And I like doing math at night. It just seems nice. I do see we have somebody checking in. That's awesome. So if you would like to submit a problem, to have me work through, answer your questions, that sort of thing, what you can do, right now everything's run through thecalculustutor.com. In fact, I can put that in the chat. Submit your questions at calculustutor.com. And I think it didn't turn it into a link. Can I edit it? Remove. Well, oh, there, good. It turned it into a link. Excellent. And I'll pin this one. All right, so that's the easiest way. When you click that link or just type in thecalculustutor.com, pretty straightforward, you will go to this page. This is my site, and it's hand built. I mean, it's built on the WordPress platform, but like we know all of the code that's underneath this. So like, yeah, it's really straightforward, simple website. You can access the stream right on the page itself. Here's a button to submit a question. That will take you to your two options for question. Oops, wrong button. There we go. Awesome. And you can see this, you can. All right, you click that, and now you can send me your homework questions or any math questions via this form. So if you click this, my hope is that it opens this form. If you are a student with say a 4J student with a school Google account, and it gives you some sort of error message or it just won't open this when you click that button, let me know. Shoot me an email. Otherwise, if you can access it, that's my hope, but I don't have access to a student 4J account to test with, so I'm waiting for somebody to let me know. If you do, pretty straightforward. I do have to collect your, you do have to be logged in, so I do collect your email address. It has to be that way in order for you to submit pictures. That's just a Google requirement. And it's important to me that you're able to submit pictures. If if you can't access it, because like your school Google account is sort of locked down in such a way that you can't, and sometimes that happens, you can't email them to me. So if you want to submit questions here, sort of read through this. This is the 4 things, and if we go back to my website, if you're just sending an email to ryan@thecalculustutor.com, you would want to include these things. This is the way you can ask, a good question. The better the question is asked, the better the answer I can give, generally. But, I'm going to do everything I can to use what you are able to provide. But here's what I'm going to need from you, and the form walks you through this. But I need whatever you would like me to refer to you as, your name or the name you prefer me to use, or your username on YouTube, or where, it doesn't matter. Just whatever you prefer me to call you, and your pronouns if you care. Otherwise, I'm probably just going to they you. The problem source, what class and what teacher is it from? That's going to help other students find your problem. And then your question, ask it as specifically as possible. So don't just tell me number 8 and then send me a picture of your entire textbook page, right? Like, no. Please do tell me, if you do send me the entire picture of your textbook page, which is fine, tell me number 8. But then tell me what your question is. Are you just not sure where to start? That's specific, but maybe you do kind of know where to start. Maybe you did start and you got stuck somewhere. So try to be as specific as possible. But your question might just be, like I said, I don't know where to start. You can say that, or it might just be this problem, but like, I don't understand. I don't know this topic at all. I wasn't there that day, or I don't think we've talked about this in class, or this problem is totally different than the one the teacher did in class. That's pretty specific, right? The more you give me, the more I can give you. And then images. the biggest thing is clear complete. So clear, it's not blurry, and if the text is small, when you zoom in, the text is readable. So don't just assume the text will be readable when I zoom in. When you send things through these, they get compressed, and yeah. So make sure I can read it. If I can't read it, I can't help you. Sorry. Uh, and then complete means make sure it's not like nothing's cropped out. But the other thing that complete means is if there's a separate block of instructions somewhere at the top of the sheet or separately in the textbook or whatever, make sure you either also take a picture of that separately or include that block of instructions in your picture. You can attach up to 5 images to the form, and you can attach, tons of pictures to an email. And if it's not a textbook and it's not a worksheet, if it's online, like through Canvas or something like that, you take a screenshot. You should, if you do an email, you can take a screenshot and just paste it right into the email. If you take a screenshot and you want to send it on the form, you're going to have to figure out where the screenshots are stored. But that should be pretty straightforward. And if you're on like a Mac, I can't really help you. I would just Google whatever you would need to Google. So just Google a little bit and you'll probably be able to figure that out. Yeah, and if you run into any trouble, you can just email me directly at that email address, ryan@thecalculustutor.com, or you can chime in chat, right? I'm here to help you get your questions answered. I want your yummy, yummy math questions. So until I get any submissions, let's focus on a useful math topic. Fractions are useful. What do you think about when you think about fractions, besides maybe sorrow and pain and regret? But what do fractions represent, right? Numbers. Some people like pure math and like just thinking about the idea of numbers, but for most of us, numbers are a tool. They're useful. They track quantity and value. And so it would make sense that, yeah, we have whole numbers. You can have 1 of something, you can have 2 of something, you can have 3 of something. But you can often also have 1.5 of something, or just a half of something, or a third, or a sixth, or a seventh, or any fraction you can dream of, right? So the fractions are the partial numbers, the not whole numbers. They're not the only type of not whole number, right? We're talking about fractions, so you might be thinking about decimals. Oftentimes there is a decimal representation of a fraction and a fraction representation of a given decimal. But that's not always true. There are some numbers that can only be most accurately represented as a fraction, like 1/3, for instance. And it can't be perfectly accurately represented as a decimal, as a finite decimal. And then there's other numbers that can sort of only be represented in decimal form. Like their best representation is decimal form. And there is no fraction they are equivalent to. A number you're probably familiar with, like this, is pi. Now, a decimal actually isn't even the best representation of pi, just the symbol pi is. That's the most accurate because it just represents the pure idea of pi. But decimal representation, you can go out as far as you want. Now, you can make a fraction that is equal to some decimal approximation to pi. You round off to 5 decimal places or something. There's some fraction that's equivalent to that. But again, that fraction would only be an estimate. And and doesn't necessarily show the sort of pattern of pi. And when I say that, I mean like a lot of people know the decimals of pi, and so that's the pattern of pi. It is not itself a repeating pattern, but it is the unique pattern of pi, of the decimals of pi. Anyway, so yeah, this partial values are really useful. They do absolutely represent things in the real world: partial dollars, partial gallons, partial hours. Oh, oops. Gotta plug in my tablet. There we go. I'm trying to keep an eye on chat and on question submissions. So if you do submit a question and it seems like I haven't seen it, go ahead and say something in chat. Also keep in mind, though, that especially if you submit via email, that might take a minute or two. Email can just be slow. The form submissions, I think, will come through actually pretty quick. All right. No form submission. So let's get into this, shall we? So fractions. So fractions are partial value numbers. You know, I'm going to try to be legible here. Numbers. Here's another thing that you probably already know about fractions. Fractions lay between whole numbers on the number line. Oops. On the number line. There you go. Follow on along. Come along, chat. Fractions lay between whole numbers on the number line, like such. We have a number line, right? We have 0, and we have 1, and we have 2. We could also have -1, right? So you could have a number like -1/2. Oops, let's make that legible. -1/2 between 0 and -1. You could have a number like 5/6. That's between 0 and 1. But then you could also have a number right here, which is going to be 5/3. That's an interesting way to write a fraction, and maybe you've learned the number on the top of a fraction isn't supposed to be bigger than the number on the bottom, and we'll talk about why that's okay. And you'll be on 2, but between 2 and 3, you could have other numbers, and maybe you've seen things written like this. You have 2.5, right? Maybe that's a thing you've encountered, and we'll talk about what that's called as well. So yeah, fractions are partial value numbers instead of whole value numbers. Now, both of these are betraying a little thing that's true, which is that whole numbers can also be expressed as fractions, but we'll get to that, right? The fractions are useful as partial value numbers. Fractions are useful as they lay between whole numbers on the number line, right? Because we already have whole numbers, fraction representations of whole numbers can also be useful, right? But yeah. Okay. So we understand they're partial numbers. I want to get into some diagramming here, which is also just going to be me a little bit playing with some of the Miro board tools that I don't get to use super often, but have used, to pretty effectively demonstrate some of this. But let's give ourselves. Okay, so this right here, actually, maybe this will be easier to do up here. Sorry, y'all. I can either control the Miro board on my tablet or on my the streaming computer. And for some things, it's easier on the streaming computer, I'm realizing. Okay. There we go. And let's call this, I'll even fill it in a little bit. Right, just a little bit of gray there. Can alignment? Ooh, there we go. Let's put this at the top. This is one hole. This is our one hole. There we go. Okay. And so one hole can be one whole anything, right? One whole apple, one whole dollar. But you could also talk about one whole of groups of things, one whole pack of Pokemon cards, right? One whole gallon of milk, right? That's one thing, but it's a lot of stuff. One whole day, which is a lot of hours, though, right? And so just because you have one whole, obviously, many types of wholes you can split into pieces, and it makes sense. Oftentimes in textbooks, when we teach this, they'll talk about the whole being a candy bar, and then we teach this by talking about, okay, well, how would you share the candy bar fairly if you needed to share it with 4 of your friends? And so you have to be like, oh, well, I need some and my 4 friends need some, so I need to break it into 5 equal pieces. And we can talk about that here as well. Okay, I want to, let's make this like this. Can I make the, oh, is it board? Aha. Ooh, look at that. That's nice, right? Okay, so here's, so if we wanted to break this into, say, 5 equal pieces, boom. Okay. Boom. Okay. There we go. I think that does the job sufficiently, right? We've now broken this candy bar, this whole, into 5 equal pieces. So how big would we say these pieces are? Each one of these, what fraction might we say it is? All right. Ah, there we go. Let's put it in the middle. Oh, you know what? I bet it's not going to let me actually like represent a fraction. Okay, shortcoming in Miro. Don't have a good way to type math, but that's okay. We can come in here and we can, that's the other thing I like about Miro. This would have to be 1/5. This is one piece, right? Each of these is 1/5. And now right away, I don't want to skip over the fact that I've just sort of like, if you've never seen fractions before, I've done something totally weird with numbers. I made a new number out of two numbers, but without like adding them or subtracting them, but like putting them in different places and putting like a little line between them, right? So let's give ourselves a nice little note over here. Oh, you know what? I'm going to totally want to color code these. Heck yeah. Boom. We'll make this one purple. Boom. We'll make this one green. And boom, we'll make this one kind of orangey. Okay. I like that because that lets me label them. Boom. This is the numerator. We'll come back to that. We'll talk about what do they represent, things like that. The bottom number, you probably know, is, we call it the, and let's put this in quotes. Well, no, we don't need to put it in quotes. This is the denominator. The denominator is down the new, that's how I might remember it. You might mix these up a little bit, and that's okay. Bring everyone to me. There you go. Sorry about that. If it wasn't showing where I had. If people are following along in chat, if the screen ever doesn't seem to show what I seem to be talking about or whatever, or it seems like I'm working off screen, totally just yell at me. I can make this follow me, but sometimes that following breaks. So yeah, all right. So numerator, denominator. I also want to mention this right here. I believe, I'm going to look this up, make sure I'm spelling it right, and make sure I'm using the right word. I think it's called the diviculum. Diverticulum. No. Okay, what's it called? I think maybe I'm just making that up. Oh, a vinculum. Okay, so it's just called the fraction bar. It means divided by, though. So this is something I want to emphasize right away. Fractions and division can't be separated. They're kind of the same thing. This right here, one fraction bar, it's called a vinculum. Or fraction bar. It just means divided by. Boom. Okay. So we can read this as the fraction 1/5, which we interpret to mean a piece of a whole that if you had 5 of them, you would have the equivalent of a whole. Now, really quick, fractions don't care about whether breaking something into pieces changes that thing, right? So, right, fractions are more of just like a measure. They're a representation of a number. So don't put too much weight on them, and don't and keep in mind that fractions are just numbers. They're not aware of situations, right? So anyway, 1/5 is this. It's the number that is 1/5 of the way to 1 as you go from 0 to 1, right? We could think of it that way on a number line. And in fact, we could totally just put a number line, say right, let's do a different color. We could do a number line, say just like right here. We could if we called this 0 and we called this 1, then this right here would be the number 1/5. This right here, which is another 1/5, would be the number 2/5. This right here would be the number 3/5. This right here would be the number 4/5. And that sort of implies that 1 would be the number. Could we also write 1 as 5/5? We absolutely could. And that takes us back here. Could we also write 0? There we go. As 0/5? We absolutely could. Right? 0/5 is the same as 0. If you have 0 of these 1/5 pieces, well, you don't have anything. And this is equal to 1. If you have, and so yeah, in fractions, having, say, 5/5 is exactly the same as having 1 whole. Because remember, they don't care about if breaking something into pieces makes it different. For fractions, if you have enough pieces, you can just put it back together and it's 1 whole. So, which is why these diagrams can be really nice, right? Like, oh, I see if I have all of these, I actually have the same thing as that 1 whole I had shown a second ago. Let's do that. And if I send to back, send to back. Can I just move? Oh, I see. It also captured the, okay. That's a little tough. So I can do, let's do this. Let's break it up. Boop, 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 boop. Okay. Group these together. Send to back. There we go. There's our 1 whole. Let me grab it really quick. Okay, I just want to have access to 1 whole, right? Now I can send the 1 whole to the back. Send to back. There we go. Okay. I just want to have access to it again. So for all math purposes, 5/5 is equal to 1. But the thing I want to emphasize is we can think of this as this amount, this distance, or this portion of a whole, anything like that. But we can also think of this as 1 divided by 5. And usually when we like combine numbers with an operation, we want to just do that operation. Like if I just gave you 2 plus 3, well, that's the same thing as 5. So let's just say 5. Let's just use 5. That's way easier to carry around and do other stuff with, other math stuff, than 2 plus 3. So why don't we just combine these? And just, what is 1 divided by 5? Well, that's the thing. 1 divided by 5 is 1/5. So this is the way. So we could also represent it with a decimal, right? If you do 1 divided by 5 in a calculator, it will give you a decimal, and that's just a different representation. It's that decimal that it gives you, and I don't even want to say what it is because we're not talking about decimals. We're focused on fractions. But that decimal gives you is just a different way to write this same amount or this same distance, however you want to think about your numbers. Yeah, I think that's a big thing I wanted to emphasize with that part of it. Just know, anytime you're dealing with fractions, you could also just think of it as division. The numerator is always being divided by the denominator. When you reduce fractions, which is something we can talk about, you're just taking this down to the smallest possible numbers that represent this distance. And so what do we mean by represent the smallest possible numbers that represent, say, this distance? Well, let's divide our 1 whole. Let's divide it into 10 pieces instead. Right? So I'm going to copy, paste. So here's what I'm going to do. Oh, it grabbed the... Let me go in and erase these. Okay. Now, grab that. And now what we're going to do is we're going to shrink this in and make it exactly half. So there's 5 there. And now if I grab this, copy and paste it. Oh, oops. There we go. Okay. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've sliced that whole into 10 slices. Yeah, this will work. Wouldn't you know it? In doing that, I got rid of my 1 whole. So I'll just put this over here. Copy, paste. Here we go. All right. Excellent. Okay. I'll go ahead and send that to the back. Okay. So if we've now split it into 10 equal pieces. So how big would we say those pieces are? We would say they are 1/10. This is 1/10. This is 1/10. And so we could do a similar thing. We could do a number line. We could call this 0, and this distance would have to be 1/10. This distance from 0 to here would now have to be a total of 2/10. And 3/10 right here would be, oops, 5/10, 6, 7, 8. Right here would be a distance of 9/10, and we could call this 10/10, but that would just be 1. And so notice what we have here. Let me zoom out a little bit. Oh, that's pretty small on the share. I'll zoom back in. Similar idea, right? We can think of it as you take the whole, break it into 10 equal pieces, or think of it as the distance from 0 to 1, break it into 10 equal intervals. Same ideas. right? But the thing I want to focus on, though, is now some equivalence. Notice that right here, from here to here, from here to here, right? Those are the same distance. And so we have that 1/5 equals 2/10. They represent the same distance. They represent the same portion of the whole. All other things being equal, if you had 1/5 of a candy bar and somebody else had 2/10 of the same candy bar and you swapped, neither of you have lost anything. You both have exactly as much as you started with. Again, remember, the numbers don't care about whether breaking something up has meaning beyond breaking it into equal pieces. Maybe one of you prefer the candy bar, your 1/5 of the candy bar then broken into two pieces. Maybe you prefer that. Maybe the other person just wants it all as one piece. That's separate from the math. All right. Oh, so notice here. So this is what I meant when I said up here about the smallest numbers that could represent that value. So 1/5 or 1 divided by 5 is the same thing as 2/10 or 2 divided by 10. And now here is where this gets interesting. If you have the fraction 2/10, you can and you treat it as division, 2 divided by 10 is most simply written as 1/5, right? And so because these numbers are a little bit more complicated, we can see that we have a fraction that when you do the division becomes the smaller one. And there's some like number tricks, not tricks, but it's just ways we can go about understanding how numbers are put together that let us simplify this and not have to understand that, 2/10 is the same as 1/5. You don't have to memorize that. You don't have to memorize how all of the fractions are related to all of the other fractions. There's some patterns you can take advantage of. That's a little outside the scope of this, what we're talking about here. But it's definitely a very good topic for another day. And so I will keep that in mind. All right. So let's talk about what it means to add or just combine fractions. So I don't want to change the size of anything. Like I'm zooming in and out, right? So everything's staying the same size relative to each other. This one hole continues to be the same size as these, holes, right? They all overlap perfectly. That's always going to stay the same even as I zoom in and out. And that's the whole point with fractions, right? Whatever your whole represents, that's what your fractions also represent partial amounts of. So if your whole represents a full one whole tank of gas, well, then your half can't represent half a gallon of gas. It has to represent half a tank of gas, right? And so, numbers are just abstract kind of ideas and tools. We apply meaning to them. And so anytime you're using a number to represent that sort of value or quantity, you're establishing that. And so, yeah, the fractions will also always mean a partial amount of whatever one whole means. So if the fractions feel confusing for whatever problem you're working on, step back for a second and say, what is one of these things? What does two of these things represent? Okay, so what would it mean to have half for that, or a quarter, or 1.5? One thing I am excited about with not just with the streaming, but also with like this tool of the Miro board I'm using and things like that, is I'll have to look more into this, but my hope is when I share notes, you can make copies of them that you can then actually more directly interact with. So I can make like a Miro board that is like fraction tools. That's a whole bunch of these basically, of a whole bunch of holes broken up into fifths and halves and thirds and sevenths, right? And you can have all these different pieces that you can then actually move around on this canvas and see how they combine to make a whole or not make a whole, things like that. Yes, we're not quite there yet, but yeah, I will be sharing these notes as we go along. And my hope is if there's like useful stuff in here that I need to share the actual notes so that they're read only for you, view only. But if you can make a copy of the board that you could then go in and actually edit, then you could have access to those things. And so as I get closer to that and I start making things like that, I can do like a tutorial about how do you use Miro in that particular way. But all right, that is a task for another time, something to focus on some other time. For now, let's talk about what it would mean. Just dot, 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 dot. There we go. Okay, can I just if I just copy that? Oops. No. Okay. Okay. Awesome. Okay, here's a 1/5. Okay. Let's zoom in here. You and your friend. One of you has 1/5 of this candy bar. The other of you has 1/10. But you want to split it so you both have the same amount, let's say. Or actually, even before that, let's just figure out how much do you have together, right? That I think that's an easier thing to, or we'd need to figure that out first anyway. So let's start there. So you have 1/5, your friend has 1/10. You want to figure out how much do you have together. And so here, let's do, I'm going to do it up top. 1/5. So we're trying to add this together. Let's do it right here in the middle. 1/5 plus 1/10. You know what would be really handy, Miro board, is if you would cooperate with me. Okay, there we go. Okay, so we just want to put them together. That's pretty straightforward. Boop, there they are. And now there it is. We have, it's 1/5 and 1/10. But like, how much is that? Like, there's got to be a better way to write that, because essentially all we've done is just still write 1/5 plus 1/10, and we haven't said what that's equal to. We want to know what portion there we go. We want to know what portion of this whole we're talking about here. Sitting back, boom, there we go. So we can see, right? Clearly, it's like less than half. It's more than 1/5. It's more than 1/10. How could we represent this, right? What's the simple number we could use so we could say compare with somebody else to see if this is more than they have? Anything occur to you? I'm excited for when we start actually getting some people in stream, and people might, mention in the chat. Somebody might shout out in the chat, well, couldn't we just do? So one thing that occurs to me, and I like to get, is that these are different things. That's what's making this hard. A 1/5 piece is a different thing than a 1/10 piece. Now, granted, we did mention up here that they are related to each other. 1/5 and 2/10 is the same amount as 2/10. They're related to each other. They have a relationship, but they are different. And I compare this, an example I sometimes use with students I've worked with is, imagine you go to a country you've never been to, and you don't, you haven't had a chance to learn how the money works, and you buy something with some paper currency, and they hand you back coins, and they hand you back one big coin, right? Like we have a big chunk right here, and they hand you one small coin, like we have a small chunk right here. But you don't know how much money you have, right? You don't know how much those coins represent. You know you have one big one and one small one. But what does that buy? How much is that? How much money is that worth? So we want to combine these and say what fraction of a whole bill, say a whole dollar or whatever, a whole franc or a whole 1 unit. Oops, sorry. I accidentally shook my desk, but the camera maintained its stability pretty well, it seems like. Maybe I missed it, but okay. So some of you might already be saying, well, let's use that relationship, the fact that there is a relationship between these. So what if instead of 1/5, since we know, let's put this down here, 1/5 is just equal to 2/10. So let's put 2/10 in there for it. So we have this 1/5. There we go. So we have this 1/5. But we know it's the same we could also just break that into, if we break that into equal pieces, well, each of those is 1/10. And now, what do we have? How many 1/10s do we have? Or what is our distance from here to here? This is 1/10. This is 2/10. So this must be 3/10. And so we know, what we just figured out is 1/5 plus 1/10 is equal to 3/10. 1 plus 1 equals 3, obviously. I say that jokingly, a little facetiously, but that is the type of thing that can confuse people when they're first learning fractions. Especially, remember how young you were when you were first introduced to fractions. You might still have been feeling really shaky about multiplication and division when you were introduced to fractions. Heck, maybe you were still feeling shaky about addition or subtraction, even just counting, right? Like, people are at all different levels, especially during those early years. Um, and then you sort of continue to spread out. Some students end up taking calculus in high school, uh, other students don't. So you're going in different directions, and everybody's at a different place. So it would be totally fine if, yeah, you felt like that. You looked at this and went, but I learned 1 + 1 = 2. That makes sense. I understand why 1 + 1 equals 2, maybe. But now you're telling me 1 + 1 = 3, and we use the 10, but not the 5 for some reason. So that's a frustrated way to look at this, right? Where you're looking at all the things that don't seem to make sense. But remember, math is all about sense making and making sense. It is the tool by which we make sense of the world. So it is itself very sensible. But what you have to find is the pattern. What is the thing that is sensible? What is the consistency? And that's what we built towards here. This is ideas of what we've been messing with here is ideas of equivalent fractions, fraction reducing a little bit. Obviously, we just did fraction addition, but we also did common denominators, but we never said the word common denominator, right? But we did do it. How did we do it? Well, we did it by instead of adding 1/5 plus 1/10, instead of adding a big coin to a little coin, we said, oh, we learned, oh, that big coin, it's actually the same thing as 2 of the little coins. Maybe you have a friend that you're visiting and they tell you that. They're like, oh, yeah, that big one, that's the same as 2 of the little ones. So you actually have 3 of the little ones. And so what we did here, this process of turning the 1/5 into an equivalent amount of a different fraction, this process, this is the common denominator process. Now, we didn't come up with a process to get there consistently every single time. We just took advantage of what we were dealing with these particular fractions. But that's where you start, right? And if you're having trouble with the process of finding a common denominator, like the mathy way of doing it, part of that might be because you don't actually understand what it is you're doing. You're just trying to do the correct process. And doing the correct process without understanding what you're doing, is a bit like following a recipe without knowing what it is you're trying to make, right? It says grab the eggs, so you grab the eggs, and it says 3 of them, so you put 3 of them. And honestly, you could probably do that and end up with cookies or whatever it is you're trying to make, right? If you just follow the recipe, and you could even memorize that recipe and do it every single time. But do you know why it works? Would you know how to then take that recipe and make a related thing? Take your chocolate chip cookie recipe and make snickerdoodles, right? Take your chocolate chip cookie recipe, and from that, figure out how to make a cake, right? Without you obviously, you could just look up a cake recipe as well. But my point being, if you don't understand what the process is, you're just following a recipe blindly, and it's not a tool for you. It's just a process you go through to get from a beginning to an end. And yes, that will probably never be useful for you in real life. But if you understand what the process is doing, that's how you make math useful for you. So from this, I think we have a few ideas that we can summarize. We haven't talked about it explicitly, but I think in dealing with this, we can come back to what a fraction is and clarify a little bit. So let me find my way back up there. So based on what we did here, we just called this number the numerator, but what is there one of when we say 1/5? Or when we think of that 1/5 as 1 divided by 5, 1 what divided by 5 what? So when you're dealing with fractions, you should be able to understand not just what the fraction as a whole, what 1/5 represents, but what the 1 in the fraction and the 5 in the fraction both represent kind of separately, because they will have meaning. So based on what we've done here, let's think about it. I think it might be easier to start with the denominator, really. So this fraction 1/5, here's our 1/5 pieces, here's our 1/5 distances. What does this what is there 5 of? Well, this is the number of pieces to make a whole. It's the number of equal pieces you've broken the whole into to obtain this particular fraction. A 7th means you broke into 7th equal pieces. A 20th means 20 equal pieces. You could do a 1,000,000th. You could break a whole into 1,000,000 equal pieces. That's what is that what micro? I think that's what the micro prefix is. So if you like a micrometer or something like that, that's 1,000,000. That's breaking a meter into 1,000,000 pieces. So yeah, the denominator just represents how many pieces you've broken the whole into, or how many pieces you would need of that size to make a whole. Pieces. The number of pieces the whole is broken into. Maybe that's a little way to say it. I don't like ending in broken into. What is that? Ending in a preposition. Number of pieces. The number of equal pieces needed to make a whole. We'll say that. Another way to think of it is they tell you how big the pieces are. The bigger the number, the smaller the pieces. And maybe that's a thing worth actually specifying here. You can come in here and say, the bigger the denominator, the smaller the pieces. Does that make sense? Why? If the denominator becomes a bigger number, why are the pieces smaller? Well, I think we can see it a little bit in just what we've got right here, right? Here's a denominator of 5. Here's a denominator of 10. So the 10's a bigger number. And the pieces are smaller because there's more of them to fit in the same space, right? One whole, once you've decided what your one whole represents for the numbers for whatever you're using the numbers for, that one whole never changes size, right? If you're talking about one whole tank of gas, then your 1/5 is 1/5 of a tank of gas, and your 1/10 is 1/10 of a tank of gas. You can't just all of a sudden say, oh, now oh, the whole is a tank of gas, but the fractions represent fractions of a gallon. Doesn't make any sense unless your gas tank happens to also be exactly a gallon. Yeah, the bigger the denominator, the smaller the pieces. Okay, denominator is the number of pieces you're dividing into. So the denominator doesn't tell you how much you have. You don't have the denominator in value, right? It's more of like a label. It's the size of the coin, it's the type of coin. So the denominator is almost like a unit. So the denominator tells us how big the pieces are or how many of them we would need. That's the same information, just in a different way. So what does the numerator tell us then? What does this 1/5 mean here? What does this 2/5 or this 3 represent, right? So keep in mind on this number line, the number represents the distance from the 0 point to that point, right? So from here to here is a distance of 1/5. But from 0 to here, well, that's 1/5 and another 1/5, so that's 2/5. And this distance from here to here is 1, 2, 3/5. And so that number up top seems to tell you how many of those pieces you have, right? If we have just down here, this distance right here, it's 1, 2, it's 3 1/10, but 3 1/10 we could also just call 3/10. And in fact, we do. And so the numerator is the number of pieces. That's how many pieces you're talking about, or how many repetitions of that distance or multiples of that distance or anything like that. So the numerator, that is how many, and the denominator is how big. So it's like a unit, and the numerator is telling you how many of that unit you have. 1/2, right? If it's a coin, that's like a $1/2. That's basically the biggest coin you can have that's not itself worth a full dollar. What was I trying to say? Sorry, I sort of lost my train of thought there. Right, but the 1/2, so that a $1/2, if you have $1/2, you have one coin, and how many of those coins would you need to make $1? You would need 2 of them. And so, and honestly, people are really we get familiar with money pretty early on in our lives, right? Because we interact with it every day. I have opinions about that, but we'll talk about it some other time. But we could, just as a for instance, right? We could talk about if you had a quarter, right? We even call it a quarter, right? This is 1/4 of a dollar. We have, you could have, oh, I put $. You could have a dime, and what fraction of a dollar is that? Well, how many dimes, if we have one dime, and how many dimes do you need to make $1? Well, they're 10 cents, 10, 20, 30, 40, 50, you need 10 dimes. So they are 1/10 of a dollar. They're what you get when you take $1 and divide it by 10, divide it into 10 equal pieces. Well, what would we call that? We call it a dime. We call it 10 cents. We can represent it with a dime. What about a nickel? How many nickels do you need? Some of you might know this off the top of your head. Others of you might go, well, a nickel is half of a dime, so we need twice as many. If we have one nickel, And we need twice as many, so that's 1/20th of a dollar. And then finally, are we still making pennies? I'm not sure. How many pennies do you need to make a dollar? So a penny is one, you need 100. So a penny is 1/100th of a dollar. We call it a cent. We call it 1 cent, right? Cent is now I don't know, Latin, probably it sounds Latin prefix meaning 100 or 100th. Centennial, per cent, you hear cent all the time. And it always corresponds to something having to do with 100. And so yeah, each of our coins represents a useful fraction of a dollar. You can combine, if you combine the correct number of them, you can have the equivalent of exactly $1, right? It actually would be really kind of strange to have a coin that wasn't a perfect split of a dollar, right? Of some variety. So you'd have to, like, if you gather 13 of them, that's equivalent to $5 or something. So yeah, so we have these pretty simple coins. Of course, we also have, I didn't put a 50-cent piece or a $50 coin here. We do have those. I think they still mint them, just in small quantities, but we don't use them very much because honestly, coins themselves aren't very useful to us much anymore. But I mean, it's kind of similar with the dime nickel thing. Like, we could probably get away with getting rid of the penny and getting rid of the dime. This can show us following the money, right? Always good advice when investigating. Following the money here can teach us how to combine some fractions, right? Or what fractions are equivalent to each other. How many nickels would you need to make a quarter? A quarter. Boop. Oh, oops. That's not what I meant to do. Oh my gosh. No board. There we go. Haha. You might already know. You need 5. 5 nickels equals 1/4. But what did we just figure out there? We figured out that 1/20th of a dollar plus 1/20th plus 1/20th plus 1/20th plus 1/20th is equal to 1/4. Do we think that's true? Oh, you can't see what I'm doing. Sorry about that, y'all. Here we go. I'm just focused down here. Oops. Okay, move that down a little bit. Do we think that's true? Well, we talked about when we were adding the tenths together, right? 2 tenths plus 1/10 is 3 tenths. These are common denominators. We didn't talk about necessarily why this makes things easier. We could just see plainly, right, that it bring everyone to me. Yeah, we could just see plainly that if you replace that 1/5 with the equivalent 1/10, 1/10, or 2 tenths, that you have 3 tenths. So we can see that distance is 3 tenths. Same thing here. So this is the same thing. We have 1, 2, 3, 4, 5. We have 5/20ths is equal to 1/4. Do we think that's true, right? We know this is true, so we're trying to ask ourselves, can we confirm that this is true? It seems like it would have to be, right? But this is a really good what I'm trying to model and demonstrate for you here is a sort of a way you can pursue or interact with any math work you're doing. Ask these sort of curiosity questions. Just when you have something obvious like this, a lot of times there's a less obvious like new thing that you're learning, right? Like you understand the money representation, but you're also learning about the fraction equivalent representation. Well, the things that you know about money, what do those tell you about the things you're now learning about fractions? Well, we can see that this 5/20ths representation should be the same distance, the same portion of the whole as 1/4, as a quarter, because we know 5, 10, 15, 20, 25 cents, 25 cents definitely works out. So this, what we're starting to build towards here, and we're getting low on time, so this is sort of a preview of where we go from here, is this starts to beg the question, okay, how do I just deal with the fractions without having to come up with some representation for them that I already understand? Because you can for a lot of fractions, but for some fractions, they're relevant to the problem you're working on, but you don't really have anything in your life that fraction might actually be meaningful for, right? Like a 13th. What in your life do you ever encounter a 13th of, right? So so it would be really nice if we could figure out some math processes where we can just look at the numbers themselves. If we just had 5/20ths, how would I know it's the same as 1/4? Or the other way around, if I just had 1/4, how would I know it's the same as 5/20ths? Because what we're sort of implying here is that there's either multiple numbers on the number line that are equal to each other, and that seems weird, or that for any given number on the number line, there's at least two ways we can represent it. Clearly, we see that here. Clearly, we see that here. 1/5 equals 2/10, right? But you might have already had the thought, well, if you can split the 1/5 into two pieces and make a 10th, you could probably split it into three pieces or four pieces. And so there'd be some other fraction that 1/5 is equal to, some equivalent amount of, 1/5 is equal to three pieces that are actually a 15th of the whole, is what that would be. And so actually, there are an infinite number of ways to represent any fraction. But there is only one most reduced or simplified representation. So this is a thing we have to grapple with when we're dealing with fractions. For any fraction, like even simple fractions, 1/4, there's actually an infinite number of other ways we could write that fraction. An infinite number of numerator-denominator combos that represent the same distance on the number line, represent the same portion of the whole, right? Because if we just go back up and think about that 1/5, right? I broke it into two equal pieces to make 1/10, but I could have broken it into 3 or 4 or 5 or 6 or a million or 2,876,592, right? I could have broken into that many pieces. It would have been a huge pain in the butt, and I never would have done it for these terms, but it is a fraction that exists. It is a fraction that could theoretically be meaningful for some application. So it would be useful to be able to grapple with it. And so that's sort of where we push to from here. We have these representations of fractions, right? And we can talk about some other representations too. These are going to be really powerful ones because they're pretty simple, but they are extendable to basically deal with any fraction situation we might deal with. We might have to first change the shape or size of our whole, but remember, when you're figuring, you get to do that initially. You get to figure out, what does one whole represent for my situation? Now all the fractions are a fraction of that whole. So yeah, so when we realize, oh, we want to deal with these sort of really funky fractions, we want to deal with, 1/111th, or multiple 111ths. We want to break the whole into 111 equal pieces for whatever reason. We could do that with this. So yeah, the couple of people who checked in early on, it was nice to see them. Nobody ended up submitting any questions, unfortunately, and that's okay. I'm going to keep at this. I was just actually reflecting after the Sunday stream, I think, or before, I don't remember, but like just a couple days ago, that like even when I was teaching in the school and doing before school and after school homework help, the first like few weeks, I didn't get like hardly anybody. Partially because it's the beginning of the school year. Students haven't necessarily realized they need math help yet. You got to feel the crunch of progress reports and midterms and all that sort of junk. And also, people need to know I exist. Hopefully word is still getting out. I have things I want, and I'm going to continue to do to try to make people aware that this exists. So yeah, I will be here. I am committed to streaming multiple times a week. I'm all throughout this first semester, maybe not 5 days a week if it really just stays really slow. I might just cut out a couple days just to save myself the time, but I don't think so. I think partially I just need to find when being available is useful. I might reach out to teachers, to math teachers, or SPED teachers, or student success teachers, and see if I can like come in and do like a brief 5-minute, like, this is who I am, this is how you access me. I hope to see you soon. Any questions? Yeah, that's a thing to think about. And just do that in a few classrooms. It'd be nice to have something to give to students for that. Probably a sticker or whatever. My partner would be excited to make stickers. Okay, well, we're done here. At this point, I'm just babbling at you. Thanks, everybody. The 2 people it looks like who stopped by. Thanks, everybody who will stop by in the future. I will see you tomorrow for more math.